Hello everyone, so in this video let us talk about one more medium level problem from LeetCode. The problem name is minimum flips to make A or B equal to C. Let's talk about the problem statement first. The problem statement goes like this, that you're given three positive numbers A, B and C. Return the minimum flips required in some of the bits of A and B to make A or B, or is the bitwise operation that A or B equal to C. Now, flips operation consists of any number of like single bit change from 1 to 0 or 0 to 1. Don't worry, we'll talk about some example to make it more clear. So before going over all the first like understanding the examples and all that, we have to first understand what is bitwise operation. Let's bring down our whiteboard. So bitwise operation, you might also learn it online as well, but I'll just give you one brief example that if we have bitwise operation and we have two bits, that is 0 and 0. This is the bitwise operation. The bitwise operation of two zeros is 0. If any one of the bits is 1, then only it will turns out to be 1. And if both of them are 1, then also it turns out to be 1. This is bitwise operation, which means that if we do a bitwise operation of two bits, then if any one of the two bits that we are doing bitwise operation of is 1, then the resultant bit is 1, or else the resultant bit is 0. Now you can also transpolate this whole example to multiple bits as well. Don't worry, we'll take some example. Let's take this example only. Let's move this. Or let's put it here only so that you can understand it. Let's say that we have the bits that like this: 0, 0, 1, 0, that is A. We have 0, 1, 1, 0, that is B. And we have to somehow get C as 1, 0, 1, and 0. Now, as we have learned that when we do a bitwise operation of two bits, let's move from left to right, or sorry, right to left. When we take these two bits, this and this, and we are doing a bitwise OR operation of these two bits, and what we want resultant is 1, that is C. We want somehow that when we do a bitwise operation of A or B, that is this and this, then we get down to this. So in that scenario, we have to do a bitwise operation of all the bits. Now, when I do a bitwise operation of these two bits, that is these two bits, both of them are 0. And as we have seen that if both of them are 0, then it turns out to be 0 itself. But what we want is 1. So in that scenario, we can turn any one of them, either one of them 1. If I turn any one of them, let's say I turn this to be 1. And what happens is that the bitwise operation of this 1 and this 0 turns out to be 1. Because we can change any bit. That is our operation that we can do. And we can increment a total operation that we have done. You can increment the total operation by 1 because we have incremented one operation. Both of them are 1 and we want 0. We can only get a 0 when both of them are 0. So we have to turn both of them to 0. So for that we have done two operations. So the total number of operations are 3 now. This is 0 and this is 1. So if any one of them is 1, the answer will be 1. That is fine. Both of them are 0. This is 0. That is fine. So total number of operations that we have done is 3, and that is the answer. That is here itself. That is 3 itself. So what we have understood from as of now, that we have A and B, and based on the result that we want, that is based on the result that we want, that is on C. What is the result that we want? We will do some operations on A and B. Now, what is the operation? If I want 1 on any bit on C, let's say I want 1 here or 1 here, then I have to ensure that any one of the bits that is on the same position on A and B, any one of can should be 1. Both of them can also be 1, but any one of them should be 1. But if you want a 0, then both of the bits at the same position in A and B should be equal to 0. That is the condition that we have to ensure. And if any of them have to violate, we have to increment the total and see how many operations we have to do. That's it. That's the complete logic for this particular problem. Let's move on to the code part now. It's also very simple if you have understood the complete logic. So let's see the code part. What we have done is that we have to take the total number of operations. So we have taken a variable that is total, that is here. Now we have to iterate over all the bits. So in an integer, as you can see here, the given constraints, it will be up to 32 bits because it's not a long integer, it's just an integer. So integer has 32 bits. So we have iterated over all the 32 bits one by one from 0 to 32. And then we'll check based on what is the ith bit on C. And depending upon that, we'll do some operation. So we'll check that if the ith bit on C, how we can check it using this particular thing, that whether the ith bit of C is set or not. Set means that it is 1 or not. If this expression turns out to be a non-zero number, then that ith bit is set, else it is not set. If it is set that it is 1, then we'll do some operation. If it is not set, we'll do some operation. If the ith bit is not set, which means that it is 0, what we have understood, that if the ith bit, if the bit that is, let's say this, let's we're talking about this bit. If this is 0, then what we understood, that if this is 0, then both of the bits above it should be 0. So what we have done is that if this is ith bit is 0, then we have to check that both the above bit, that is A and B, on the same position should be 0. If they are not, we have to turn it to be 0. And for that, if they are not 0, then we have to turn them to a 0, and that requires an operation. So we'll increment the total. If they are already 0, we don't have to do anything. That is just that if those are already 0, don't do anything. If they are not 0, then increment the total, because we have to convert it to 0. If the ith bit in C is 1, then we have to just check that either of the positions on the same bit on A and B should be 1. Like any one of them can be 1. So what we are checking is that if the position at A is 1, or if the position at B is 1, then it is fine. If both of them are not, as you can see that we have exclamation mark, that is not. If both of them are not, you can say 1, then we can turn any one of them 1, that is doing one operation. Okay, that is, if any one of them is 1, then it is fine. If both of them are not 1, then we have to turn it any one of them to 1, and that's it. So this is just a simple, as you can say, for loop that is still 32 operations only. So this is like some sort of a constant operation, that is a constant runtime function only, because it will only run till 32. And that's it. That's the complete logic and the code part for this particular problem. If you still have any doubts, you can mention down in the comment box of this particular video. I will see you in the next one, coding, and bye.